Okay, guys, so here we go. Example 1, part D. Our new axis of revolution is x equals 3. Now, what's different there? X equals 3 would be, I put away my orange, here we go. X equals 3, well, you know what? You'd find 3 on the x-axis, and I hope you all remember that x equals 3 would be a vertical line, wouldn't it? So here's the idea. This time we're going to swing it this way, around a vertical line. And so that requires different logic. Now once again, we have the same two curves. All 6 questions you have, you're going to have the same 2 curves. So identifying where they cross and all that will be already done. Make sure you get it right on the first one, or you're going to miss them all. Okay, so x equals 3 would be a vertical line. So here's the visual that we need to work with this time. We're going to use what's called cylindrical shells. We use that when we're revolving around a vertical line, such as x equals 3, or in general, x equals k. X equals, vertical line. Also, after we enjoy this one, then we'll revolve it around the y-axis, which is also a vertical line. And isn't that just a special case of this, where y would equal, or pardon me, where x would equal 0. So if they reference the x, I keep saying it wrong, sorry. If they reference the y-axis, that'll be x equals 0, won't it? And maybe that'll come up pretty soon. Okay, now, here's the other thing to go back to. When we're going around a vertical line, now we're going to go back to our good old upper-lower. All right? And so that test point in there, upper, 23, is higher than 15. So now we're back to upper-lower. And so visually, this 23 being the upper of the 2 numbers would represent this upper green one, and then that would represent the lower red one. So we're back to that again, so keep that in mind. So here's the visual I would like to present to you, and I got a million markers in my hand, and I'm trying to get them all taken care of. And I want to get my colors right here. So here's what I would tell somebody. Think about a representative of this. If we bring this and swing it around this way, vertically, around the vertical line, right? Then wouldn't the mirror image hit the board over here, somewhere, and somewhere? And the visual I'm trying to conjure up would be this. You want to think about one individual occurrence. It's like we're traveling from 4 to 9 and creating geometric figures for every value from 4 to 9. So what I tell people is to just think of a random number between 4 and 9 and call it x. I'm trying to get my colors correct here. Okay, so some random number, somebody tell me to stop here. Stop! Okay, so here's x. Just a number that represents all the numbers between 4 and 9. I would tell you that for that value of x, come up here and connect the 2 curves with a vertical line, okay? And I'm trying to draw it in purple there. You'll notice purple will be the color in your notes. And so that line that connects the 2 curves is going to swing around this thing, and it's going to hit the board again clear over here. And what we're trying to conjure up in your mind would be that every value of x between 4 and 9 is going to generate a cylinder, a cup, if you will, all right, that looks vaguely like that. I didn't stretch that very well. This should be symmetrical over here, but you get the idea. All right, so what are the components of a cylinder? We have the height of the cylinder, and we have the radius of the cylinder. Those are the 2 components of a cylinder. And the idea would be that if you think about it, that's my phrase, if you think about it, but the surface area of that cylinder, if you added them all up, see, this is like a series of cups that are stacked concentrically, one inside the other. And if you could add up the surface areas of all these cups, of all these cylinders, you'd have the volume of that 3-dimensional figure. So surface area of a cylinder is the foundational formula for this particular technique when you revolve around a vertical line. Does anybody know the formula for the surface area of a cylinder? If you're looking at your notes, it's right there in front of you, okay? So look, we give it to you, but you could go look it up if you had to. The surface area of a cylinder is 2 pi RH. And I would point out to you, this is why I was looking at the colors, I underlined the R in blue, and wouldn't the radius of each cylinder be this particular dimension that we'll reason out here in a minute, and then H would be that dimension. So, there you go. Let's get after it. Won't the volume of this be, okay, this time the multiplier out in front is 2 pi, that's a constant multiplier, and we're going to add up the surface areas of all the cylinders for every value of x from 4 to 9. That's what that integral does. It travels from 4 to 9, and it adds up all these expressions that we're about to pop in here. Okay, radius. Well, wouldn't the radius be the distance from that value of x back to your axis of revolution? So, I hope you would agree that the radius expression for every value of x between 4 and 9 would be that value of x minus 3. I want to remind you that 3 is our axis of revolution. So, again, that would be underlined in orange. And then this would be the radius of every one of those cylinders for every value of x between 4 and 9. All right? And then the height, wouldn't the height be the distance between the two curves, which would be upper minus lower, which in this case would be this minus this, wouldn't it? Okay? So height, purple, would be upper curve minus lower curve. I've written too big here. Let me see if I can pull this back a little bit and make myself a little bit more room. Upper minus lower. Negative x squared plus 22x minus 62. We identified as being upper because 23 is above 15. Minus lower. That one over there. X squared minus 4x plus 10. Boom. Okay, here's another thing about this. I'm supposed to count this entire thing wrong if you forget to put the with respect to x dx on the end. I hope you see that there, dx. I don't know if I'm going to count it wrong if you forget that, although of 6 points maybe I should take off 1 if you forget that. So just remember it. And so look, what's the general expression? You guys see it in front of you. 2 pi, integral from a to b, x minus k, and then f of x minus g of x. And f would be upper, g would be lower, and that's identified by your test point in the middle. 23 is above 15. So now we're talking about upper, lower again. So that would be it, and then, you know, what you would do algebraically would be to distribute the negative here and combine like terms, and then you would distribute this with all that, and it's a bunch of algebra, and then you'd integrate each term using the power rule, and then you do the upper f of b minus f of a. On this one, whatever number that becomes, make sure to multiply it by 2, and then pi. So, you can practice this one if you want, it's up to you. That's all mechanical stuff, that's extra credit. So that should come out to be 291, etc. 291.6 repeating. Apparently the integral was half of this, and then half of this times 2 made that, and then pi, and boom. And then let's put units cubed, and that'll give you a couple extra credit points if you choose to take on the algebra and the mechanical things that follow. So that's part D, and so we'll do 2 more of these where we'll practice revolving that around different things.